triangles or any figure congruent. So we're going to talk about the parts of congruent triangles and any figure, which is called a polygon. Any shape, any sided shape is a polygon. So let's talk about triangles, congruent triangles. They will be truly congruent. What does it mean to be congruent? Exactly the same shape and size. Same shape and size. So all of their corresponding parts will be congruent to each other. So will you fill this in? Two triangles or polygons are congruent. They are congruent if the corresponding sides and angles are congruent. If all the corresponding sides and angles are congruent, the ones in the same spot. So these markings on these two triangles are telling us what parts are congruent. So we can use the diagram, and we can also use the congruent statement. This is called a congruent statement. It's telling us how the triangles are congruent with each other. So this is the time that you have to put the letters in the triangle in order, because how you note them is supposed to tell you what parts are congruent. So this one started out with triangle A. So look at A, it has one mark. On the blue triangle, which one has one mark? D, so they had to put D first with A. And then B has 3 marks. Which angle over here has 3? E, that's why B and E are both second, and then C and F both have 2. So noting the order of how things are congruent, you do have to write the name of the triangle specifically to match the corresponding parts. They can also tell us the sides that are congruent. Side AB has 2 marks, and so does side DE. Side BC has 1 mark, and so does EF, and then AC and DF. So the way that we name congruent triangles or any figure has to follow the order of what's congruent to what. So let's fill in what is congruent to everything. Focusing on the sides first. This little symbol means congruent. So side AB is congruent to which side in the blue triangle? DE. So we make a segment DE. Side BC in the yellow is congruent to which side in the blue? EF. Good. How about side CA? FD. So the order isn't detrimental on these. It should take either order. If you wanted to really be specific, you could match A with D and B and so forth. But I think that's fine. Somehow I lost my angles here. Let's look at the angles. So angle A is congruent to which blue angle? Angle D, and angle B is congruent to angle E, and C, angle F. So the diagram, the way it's marked, will help you know what's congruent to what, but also if we only had the congruent statement, that would be enough, because the order has to tell you A is the same as D, B is the same as E, C is the same as F, and we can also figure out the sides by the order of the letters. So you do have to name them according to what is congruent to what. Okay, so this would be a type of a problem that you would see. The triangles are congruent and their corresponding parts are marked. So you have to name all the parts that are corresponding and then complete the congruent statement. So look at the diagram. What's congruent with angle A? Y, good. What's congruent with angle B? Z and C, X. How about side AB? YZ. Okay, so again, that order is not detrimental. It's only detrimental when you're naming the triangles themselves. How about side AC? YX. And side BC? XZ. Good. So when we name the congruent statement for the whole triangle, you can let the diagram help you, or I think it's really easy just to follow the angle section. Because if we've already got A, B, and C, they went ACB, so we have to follow that order. So according to the angles we wrote down, what angle matches angle A? Y, and then C matches X, and then B finally matches Z. So the diagram can help you do the triangle congruent statement, or the angles that you just wrote down will also help you know which ones are congruent with each other to make that correct. Okay, let's take a look at some other ways we can use our congruent figures. So they tell us triangle LMN is congruent to triangle RST. So we know what's congruent to what by the order they listed them in. We're being asked to find the values of X and Y. So look at where they all are. Which do you think we have to find first, X or Y? X. Yeah, because this one has both. So if we can just find X, that's going to help us here. So let's take a look. We would need this angle right here to help us figure out this triangle. Look at the congruent statement. What angle in the first triangle is congruent with angle T? N. Yeah, we got T and N at the end, so 63 degrees is the same on angle T, so we can put it there. So there's enough for us to create an equation. Let's add everything together, and what should it equal? 180. So we got 3x plus, can someone get a 63 and 93? 156. And that's got to equal 180. Let's just solve that. Minus your 156, what's left? 24. If we divide by 3, x is 8. Okay, so that's part of our answer. Now we can use that to help us figure out y. What was 3x? 24, or 3 times 8. So that's 24. Okay, so 3x plus y is representing side SR. Look at our diagram. What side matches with SR? LM. Do we know the length of LM? It is 43, so we can do 24 plus y has to equal 43. Minus that 24, what is the y? 19. Yeah. Y is 19. Good. So the congruent statement is going to help you know what is congruent to what. Any questions on that one? Okay, let's look at the next one. So this applies to any shape. This one's a quadrilateral, but it's telling us they are congruent with the congruent statement. So again, we need to find the value of x and y, and this one has both, so I would focus on the one that only has one. 2x minus 4 is representing side QR. So which side, according to that statement, is congruent to side QR? GF. Everybody agree with that? GF. Do we know the value of GF? What is it? 12. So let's let 2x minus 4 equal to 12. Then we can solve it. Just add your 4. You guys, what's 12 and 4? 16 divided by 2. X is 8 again. Okay, then we can let the x in this part be the 8. Or 6y plus 8 is representing angle Q. Look at this statement. Which angle corresponds with angle Q? Yeah, Q and F are both third. And there it is. So now we know 6y plus 8 is 68. If you minus 8, what do we have? Good, 60 divided by 6, what's the value of y? 10. Yes, it's 10. Any questions on that? Okay, I might have given you one where you're going to have to create a system. I can't remember if I did, because both of these will have x and y. So you might have to say like, okay, 6y plus 8 equals 68, and 2, or that was an x too. 2x minus 4y equals whatever, and do a system with elimination. I can't remember if I did or not, but you might have to, if there's both x and y on both. Okay, another way that we can show that figures are congruent is if we can use a series of transformations, like translations, rotations, reflections, to make them actually land one on top of the other and match it perfectly. That can also prove they are congruent. So if you'll fill this in, if you can use transformations, a series of transformations, to get those triangles to line right up with each other, matching one on top of the other perfectly, then that is a way to prove that the triangles are congruent with each other. So this diagram, it's kind of hard to tell on your notes, but what they're doing is this is saying they're going to translate or slide triangle ABC over until their vertices are meeting. and then rotate it down until their bottom sides are meeting like this, and then reflect it over that line, and they'll be matching. They'll be totally matching. So that proves they are congruent, and they've marked the parts that are congruent already, but we can do that. So if we can manipulate one figure using transformations until it matches the other one, you can prove they are congruent. These are marked, but I just wanted to demonstrate this for you, that if I rotated this triangle JKL so that it's sitting oriented pretty much the same way, and then translate it over there and line it right up, they would match exactly with each other, showing the parts that do actually show corresponding and congruent. So they are congruent because we can use transformations to show. I had to make this one backwards to do the demonstration. So we would just maybe make sure you know that's a J, this is an L, and this guy is a K. And let's make our congruent statements down here. So let's start with the sides. Let's start with the sides marked with one mark. Let's start with PR. Side PR is going to be congruent to which side on the other triangle? LK. Is everybody LK? Okay, let's go to the side marked with two marks. We've got a QP, and which one is going to correspond with QP? L, is it J? I covered it up. Okay, then the last one with three marks, QR, matches with, say it again please, JK. Now we can do the same thing with the angles. Let's start with Q that's marked with one green mark. So angle Q, what's the green one mark on the other one? Angle J. And then go to the two marks, angle R matches with angle K. Should have made it so big so we can still see it. And then angle, is it P? Yeah. Angle P is going to be congruent with angle L. So let's make our triangle congruent statement. Let's do triangle QRP is congruent with, you can either use the diagram or use the angle congruencies you just made. It goes with Q, J, so J, and then R goes with K, and P goes with L. So we have to order them so it shows the angles and the sides that are corresponding and congruent. So if you can manipulate the figure to land right on top of the other one, it can prove it is congruent. Okay, here we've got two triangles kind of connected together in an interesting way. They want us to find the measure of angle BDC. Focus on that, BDC. So this whole angle right here. I've got part of it is 30, but I got to figure out the whole thing. Those markings can help us know some angles. So look at the diagram. How big is this angle right here, angle B? 45, because it's marked the same as the other one. How big is this angle C down here? 30, okay. So that's what we know for sure. Is that enough information? Yeah. Luckily, that did create all of the big triangle on the right side, triangle BCD. So we can go ahead and use what we know, 180 minus what's 75. So how big is angle BDC? 105 degrees. Yeah. Luckily, we didn't have to do a whole lot. We could use vertical angles somewhere if we had to. A couple different things that could be used there. Here's another diagram with certain things marked. It doesn't have every part and piece marked, so we can't just assume they're congruent until we do a little bit of digging. So what do we know right away is true about angle D? It's the same as, yes. It's also 68. Are there any other angles that we would know for sure are the same? R and C, how would we know that for sure? Okay, we're going to actually get into learning some of those little tricks next week. But for sure, there's no markings on R and C. So at this point in our knowledge, we don't know that for sure. But what about these two?
are the same, except vertical.
They're vertical. Yeah, so if these are the same, we've got two angles that are exactly the same. Does that default that the other set? Yeah. Yeah, because they're gonna add to 180, subtract that from 180, and that value is gonna be the same. So Devin was right, and we're gonna see why in the near future, that angle C is also 75. Then we could find these two verticals, but we're being asked to find angle DCN, and we just did. It is the 75 degrees. Yeah, it is the 75 because we do know for sure vertical angles are congruent. And if we have two of them, then that's gonna for sure be the remainder of the 180 of 75. Okay, good. Okay, here's our last diagram, I believe, and we are supposed to find X, Y, and Z. How could we find angle X? Angle X, Nick.
81, you can do the vertical angle.
Perfect, throw 81 in there, yes, and that's gonna help us finish out that triangle. What's 34 and 81? 115, so 180 minus 115 is 65. Okay, so that's X. What about Y? It's 6. Does everybody agree with that?
Yes.
We can say that because we've got the 81s are matching, and these X and this one is matching because they have the 2 marks on them. And so, yeah, from the 2 mark to the 81 should match the 2 marked angle to the 81. So yes, that would have to be 6 if we rotated it up there and lined them up. Y would land on 6. What about Z? Plug in the 65, perfect. We can plug in the 65, but look at the mark. Do we know what that one is?
34.
It is 34.
180
minus is how much, sorry? 146, perfect, because we have a supplementary angle happening there. Good. Okay, so we know now about congruent parts and pieces, we know vertical angles, we know supplementary angles, we know triangle 180s, exterior angles, all the good stuff. We're putting them together today with our congruent polygons. Hey, you might have a system. I can't remember if I assigned it to you or not, but if you will grab a piece of paper, let's title it 12.2. We'll be on the guidance again today. Congruent polygons. You do have several check answers, 5 or so. I can't remember. And today is the 21st. So if you do need to